Hey, so yeah, I have this presentation here that I gave in a local meetup 2 years ago, I think, and I thought I could share this idea and hope it's useful for you. It's about queues and async applications in Laravel. So yeah, I'm Tony, by the way. I work for Made with Love, and this is the most recent picture of our team. Um, yeah, let's talk about queues. Not these boring queues, but more fun ones. Before we dive into any terminologies, let's start with a problem that we want to solve. And if you search for queues and examples, you're going to find a lot of examples that use emails, sending emails as an example, and that's useful, really useful. But yeah, there are a lot of examples of like this. So I want to do it a bit differently. So yeah, let's in our problem it's a server provisioning service, which pretty much like Laravel Forge, if you're familiar with the Laravel ecosystem. It's a service, a web application. It's a web server. Well, it's a server. It's an application that creates servers in cloud providers, basically. And these servers are provisioned with several tools that you can use to host your application on it. And the idea is that this application creates a server instance in the cloud provider, and it has to wait it to boot so it can provision the server, like install PHP, install Git, and other services. And then it notifies the user that the server is ready. That be like application notification or Slack message or email or whatever. And so this is the current infrastructure of our application. We have the app server and the database, and this is our current implementation. So we have a server's endpoint which users can send a post HTTP request to it, and once the request hits our servers, we talk to AWS and we wait for a response. And when the server is ready, we have to provision it, and after that we create the model. This is our Eloquent model server. We create the model, and then we can send the message to the user and the notification, and then we return that to the HTTP request that we got. But this piece of information, this piece of the code, actually, this can actually be really slow, like natural. It depends on network and all that, so it's time consuming. And whenever you have something that takes some HTTP request that takes some time, your browsers don't like that, so they time out the request, and you pretty much screwed from that. So yeah, here comes the queues to rescue us. So instead of having a single application, and we now have two different pieces. So we still have the post to /servers in our application, which creates them. But the difference that before we were not creating the server model right away. We only created the server after it provisioned. But now we create it right away. And with that server, we can set some status on it. So it's, in our case, we set the creating status, which means that the server is created, and so we can't do anything yet because it's not ready. And then it pushes a message to the message broker. This message is some JSON serialized content message, basically. And this message, it's going to be living in the message broker for a while. But what's good is that we can already answer the HTTP request right away with what we got, which is the server that the user wants. And once after the message is stored in the message broker somewhere, we can actually have another process which keeps constantly listening for the message brokers, seeking for new messages. And when it receives a new message, it marks it as reserved, and then it can act upon this message, which is here we queued this create server, and then it talks to the worker talks to AWS, creates the server, and once that's created, it marks the server model as provisioning and deletes the job, and then it queues another job so the server can be actually provisioned later in another message, which can be picked up by the same process, the worker process, or even another different process at all. So we talked about it, but let's describe them a bit better. So two new pieces of infrastructure were added, like the message broker and the worker. A message broker is some intermediary tool that is used to easily send messages between two applications or two services. This tool can be, there are several implementations, several tools can actually fit this role of message broker. In our case, we are using Redis, but that can be anything from the database to RabbitMQ to beanstalk-t to the file system, whatever your application, whatever suits your application needs. And then we have the worker. Some workers basically some application or process that acts as a consumer for the message queues, and it literally is an infinity loop that keeps asking the message broker for new messages if it has new messages, and if it has new messages, it processes them. It can be a different server from your web server, and it can even be in a different language. As I said, the message sent to the message broker are serialized. It can be serialized to JSON, which is basically every language understands JSON. So your worker can be in a different language than your web application, basically. As long as it understands JSON, it can process the messages. So this is our current infrastructure. With the two new pieces, we got this. So yeah, we had received requests from the user over the internet to our web application, which interacts with the database and sends message to the message broker so it can be processed later. And then we have the worker piece, which keeps listening for new messages in the message broker and processing them, interacting with the database. So yeah, if you're dealing with queues, you know that you can split your workload into different jobs and send this job to different channels, so you can actually scale, have five workers working on channel default and 2 workers working on channel images optimization or whatever. So yeah, you can split your job into channels and have that have the scaling of those being customized by the load needed. Also, if you're using a cloud provider, I would advise to choose a good message broker. Like AWS has SQS, which is the queue implementation service they suggest. unfortunately, I like using Horizon, and Horizon only has a Redis implementation, so yeah, I have to stick with Redis, and it's true, by the way, it's not limited at all. So in most cloud providers, they also offer some Redis solution out of the box, usually in the form of cache. Like AWS has a Elastic Cache, which implements the Redis protocol. So you can actually use Horizon with AWS Elastic Cache. Another thing is you have to be aware of concurrence problems between the workers and resources they use. For instance, you can have different message sent to the back to the message broker and being picked up by different workers at the same time, and these messages reference the same server ID, for instance, so they are concurring against that same resource, so they can be updating, and something can be lost or some problem can be it can achieve some lock in the database or whatever. There are some ways to mitigate this. Laravel also offers this atomic locks feature that you can use. So yeah, be aware of that. Also prepare for failure. What should happen in case some job fails in backgrounds, like the user won't know that, and your team has to act upon the failure so to fix it. So yeah, prepare for that. By the way, Horizon offers most of these problems. Horizon also handles for you. So yeah, I'll use Horizon. This is our current infrastructure, but there is a problem with that. Let's say the web app sends a message to the message broker to be processed later, and the worker picks that message and finished the job, but the user doesn't know that it finished. How would they know? They have to keep refreshing until something changes in the UI, and that's not fun. Hence WebSockets. This part of the presentation is heavily based on this real-time web apps with WebSockets, a presentation given by Igor. I highly recommend you check that out. I took the concepts he presents and the way he presents it and appended it in this application, but I highly this presentation, but I highly recommend you check this presentation out. So yeah, let's talk about WebSockets. But before we talk about WebSockets, let's talk about the web portion of it. So when we talk about web, we are usually talking about HTTP, which is a layer 7 protocol. When we talk about networking, usually what is used to reference protocols is the Aussie model. So HTTP is a layer server protocol, which means that it's an application protocol. Basically, the Aussie model has different layers, and that was what it means basically. Like layer 7 is the 7th layer here in this model. So yeah, HTTP is a client-server protocol, communication protocol. So a client sends a request to a server, which processes it and sends back a response to the client. HTTP is stateless, and it's also media independent, which means the idea is to send files back and forth. So that file being HTML, CSS, JavaScript, or JSON, or video, or whatever, HTTP can deliver it. There is also some capabilities, some caching capabilities, all authentication, which is implemented through headers and all that in HTTP. So yeah, you can do a lot of stuff with HTTP, but not everything. Now, going back to WebSockets, let's talk about sockets now. When we are talking about sockets, usually we are talking about TCP sockets. And TCP is a layer 4 communication protocol. TCP is it's connection oriented. Also, the communication inside the protocol is driven by, it's broken into envelopes and packets, and these are delivered piece by piece. The TCP connection is persistent, which is interesting because the HTTP connection says it's stateless, so it doesn't keep state around, but the persistent connection, the HTTP is on top, it's a layer 7, and it's on top of TCP, at least the version 1 and 2 that we know. And HTTP says it's stateless, so it doesn't hold state from the server. But TCP actually provides some stateful capabilities. HTTP just throws that away, basically. So yeah, let's now talk about WebSockets. WebSockets, it's a layer 7 protocol, like HTTP. So it also uses TCP. Some people say that WebSockets is like TCP for the web, which kind of makes sense. So it enables bidirectional full duplex communication between your web browsers and servers, and that means that both the browser can send data to the server over an HTTP over a WebSockets connection, and also the server can send back to the browser some messages without the browser actually asking for it. Some common implementations of WebSockets, there are some paid ones, which is Pusher and PubNub. These are services that provide WebSockets connections for your application. There are also some pretty interesting implementations, which is like Phoenix is a Elixir web framework. It's a web framework in Elixir, and it provides WebSockets out of the box for you, so that's awesome. In the PHP world, we have some async PHP capabilities. One of the most common, most trendy ones is React PHP, and with React you can actually achieve WebSockets in PHP, which is pretty awesome. And that's actually what we are going to be using for our demo. So where does it fit? In this picture, it fits right here. So your user is going to request a page to your application, and it's going to send back HTML, CSS, and JavaScript. When the JavaScript boots, it connects to the Pusher server, and then it keeps a persistent connection here. Your worker can also send message to this Pusher server, and that message gets delivered to your user's browser without them asking for it, or without them needing to refresh. In our case, we are not going to be using Pusher, but Laravel WebSockets package, which is this awesome package from Beyond Code. Both Freek and Marcel worked on this, which is awesome. So yeah, let's go to the demo now. To the demo. So yeah, this application is already using the package. This is the message sent in via WebSockets. This application is using Docker, so I have here a PHP Docker Compose service that handles web requests, and that's what's presenting this page for us. And I have a database, a Redis, a WebSockets, and a worker process. So the idea of this application is it's going to be creating service for us. So as you can see, it's the server is being provisioned and it's now ready. You can see the logs and all that. This is cool, but let me show you one of the problems. Like, I have a command here, fake servers, which can create fake servers, basically. Just so I can show you one problem with load. Like, currently I have one worker, which means that it's going to be processing this message that the message broker receives one by one, first come, first serve. So we can actually see that some of these jobs, they take some time, so the worker gets a bit busy. So it's going to be processing the requests one by one, and yeah. Then it's going to provision one by one, and the provisioning sends another job which is going to be handled one by one as well. But what is cool here is that we can actually scale this up quite easy, because since we have a message broker between the layers, the web application and the worker, we can what we can do is actually we can scale the worker pretty much infinitely. In our case, I'm going to scale it up to 5. So right now, yeah, I have 5 workers. This is alias for Docker Compose, so I'm using Docker Compose here. Yeah, right now I have 5 workers, which is going to be processing the message. So you're going to see that it's actually processing way faster than it was before. Now it's provisioning, and then it's going to mark them as ready. So yeah, you can scale. The idea is that you can scale your workers as you need. So it's the presentation. The implementation is going to be sent to this repository. I'm going to be pushing some changes that I've done to add the Laravel WebSockets server and other updates, but yeah, that was it. Hope you liked it, and see you.